Hello Paul and the most excellent community of developers with interest in Raspberry Pi and GPIOs and LEDs, more specifically RGB LEDs, 3-color LEDs, and a little bit of object-oriented programming today for the fun. Okay, the project here is to drive an LED, 3-color LED with 3 push buttons, one for each color. So I will start with showing you my diagram here. Sketch. Okay. So if you have seen my previous video, you know that I have to work with a slightly different diode LED, which is a common anode LED. So in my case I have to plug it on a positive 3 volt here, okay, and then you have common anode, three inner diodes, of course, resistor. In my case I take 220 ohms and I will have here the RGB diodes, and I will plug this in a pin 33, 35, 37. So this is not different from what I did before in the previous video where I explained the difference between a common cathode LED and common diode LED. I will use here the push buttons with the inner resistor. So we'll finally hook this to the ground and use the common rail for the ground here. Here is my switch. And first a switch here will go to pin number 18, and it will be used for controlling the blue button. Okay. Next pin here will be 22, and I will use the 22 pin for the green. Here, and finally 32, pin 32 here will be used for what? As you guess, for the red. And that's it. Now we have the complete battle plan. So what's next? Let's have a look to the code. Here. So it's moving. So you see the 3 buttons with the respective colored caps. And some specific here. You can see the wiring that corresponds to the schema we saw just before. About the code, we will have the need of working either with the color or the pin, and we have to somehow find a relation between a button, an event, and an LED, part of the LED. So to make things easier to manipulate, I've created a class that I call a component, which will stand for generic component. It can be either a LED or a button. What is in common? Be it a LED or a button, there will always be a pin and a color. And there can be a state too. If you take the classical approach for the buttons, you remember that we had to store the logical state of the button, just to avoid toggling during the loops. So it makes sense to have a state too. And the LED will have a logical state, which will be true or false, that can be used in the GPIO output. So a component, generally speaking, will have a pin number, a color, and a state. If we want to toggle the state, which will be useful too, we can have here a method, internal function that we call toggle, that will flip the state of the component. Okay, I think it's simple enough to be understandable. Those components will be accumulated or stored in what I called here a component list. Component list will encapsulate a list, an array, in the internal variable, instance variable, or property list here, and we can append component to this inner list with the method push. I push a component into the list. This is how I feed the list. Now my utilities here. I can get an array of all the pins, an array of numeric values representing the pins used in this list. So it will be get pins. Okay, returned here the pin of each component in the list. I use a comprehension list here to make it easier to avoid looping on the list, etc. It's direct here. When you use comprehension list, you somehow define what should be in the list, in the final list. So in this final list there will be the pins for each element in the list. GetColor. GetColor is a method that returns a color given a pin. So I use the same approach with the comprehension list, with a filtering here. If B pin is equal to the required pin, and I take the first element. Normally there should be only one. Okay, I have the symmetrical method here that gives me a pin given the color. And I have two other methods here that will return a component I can get a component here by its pin. Same principle, comprehension list, first element. Or I can get a component by its color. And I can get all the components by the method all. Okay, let's see how we will use this. We can here instantiate an LED list, which will be an instance of component list, and we push 3 components that are the LEDs. So, as we said in the schema, we have a pin 33 that corresponds to LED red, etc. Okay, same for the button. We use the same class, component list, and we push component representing the buttons. We'll talk about event handler just a little bit later. We set the mode on a board here as usual, and that's where we can use the list of pins. We set up out for all the pins of the LED list, and we set them up at the initial high, because once again I remind you that we are here in a specific case with a common anode, so we have to start with a voltage equivalent. Okay, with a common anode, if you put high on the cathode, it will be equivalent to no signal, because there will be no potential difference of potential, so no voltage, no drop current. Okay, for the button list here, we get the pins of the button list in line 68 here. We set them in mode in, and we activate the pull-up down mode. It's a pull-up down up here, so it will use the internal resistor. What is new here is that we will use the windows wide enough. Maybe go to next line here. Okay, we use a comprehension list, not to get a result, but just to loop on all the pins of the buttons, because unlike setup method, the add event detect works only with one pin. It waits here for a pin number. You cannot give a list of pins with this method. So we have to loop on all the pins, which is here for pin in button list get pins. So at each step, pin will be fed with the pin number of the current element, and on this element we can add an event detector, which will be wired somehow to what we call a callback method, which is here btn event, button event, that we have defined here. So a callback method is a method that is called by another method in certain circumstances, if this method is a handler, event handler. Okay, bounce time here. I'll let you check the documentation for more explanations. In fact, in real life we don't have exact drop of voltage. There can be a little bit of fluctuations, and this allows us to take this into account. Okay, so from that moment each button will call the function button event when pressed. And how do we do the difference? How do we know what has been pressed? Because an easier way could have been to define one callback method by button red event, button green event, button blue event, but here it's the same method that accepts all the events coming from whatever button. What is interesting is that the callback method can get in a parameter the channel. What is called the channel here is the pin number that has been used. What pin have you activated? And as we said before, we have set component collection, component list that can give us a color by the pin or a pin by the color. So when I retrieve here, I will print the channel for debugging, for showing you. When I will get here the pin on which the event has occurred, I can retrieve the button. For retrieving a button, I have on my button list, I have a method get by pin, and I use the channel as an argument here. Then I have the button. When I have the button, on the button I can know the color. Okay, button dot color will give me the color of the button corresponding to the channel activated. And with this color I can get the LED, the LED. What LED should I manipulate, should I drive from that event? The LED, I can get it by color. Okay. Color is the bridge between button and LED. So on my LED list I can call get by color and give it the color of the button that has been pressed. Then this step I have the LED, and I can call the toggle method on the LED, which will toggle inside of the LED, the component LED, the state of it. And for debugging purpose, I will here display the color of the LED and either on or off following the state. Okay, you see how using object-oriented programming can make the code, main code, much more readable and practical. Okay, so from now on we can just start looping while true, etc. Well, on each step of the loop I will check all the buttons, all the LEDs. Okay, the buttons are handled by the event handler, so all I have to do is to check all the LEDs and I can here for each LED activate or update the value of the corresponding pin for the current LED to the state of the LED. It would be to the state, of course, but as we are inverted, because it's a common anode RGB LED, we will use the not LED state. It's just reverting. Then I sleep 5. Okay. 500 milliseconds, just to have the opportunity to see something. Okay, let's launch this. Okay, already news. Why is it? I press red, it's red. I press red again. Okay, you see here the debug. It's pin 32, button event 32, and red is on. Okay, logical on. I press again. 32, button event 32. This is the channel here, 32, and now it's off. Okay, then the green on, off, and the blue on, off. And of course I can combine, it can be red and green and blue. Okay, of course the camera webcam doesn't reflect the richfulness of the colors in real life, but I can assure you that it's a really right color. Yes, I turn off red and blue, and okay. You can make all combination that you want. Okay, it's all off. Then red again. And then Control C. Oh, nice. Exit. Okay. Well, hope you enjoyed it. Thank you for watching. Have a good time, and see you soon. Good cold coffee, not ice, yes.